Okay, so today, when you see a graph like this, you should be able to write the equation for it. And anything that bounces like that is either degree 2 or 4, or could even be 6 or 8. As long as it's even, it's going to bounce. So this spot right here, I could make it, let's say I said it was at -2. I could write the equation, x equation like this, and then I could square it, or I could put to the 4th. That would work, because that's also bouncing. All right, I think some of you guys had a little trouble when it was like this. It was squared in there, and then it was like cubed out there. So which is it? Is it bouncing or is it snaking? Well, when you put this to that, you've got x to the second to the third. You really have x to the sixth. So what's it doing? Bouncing or snaking? All right, this one I just made a cut through. That's a single root. But if I wanted to make a snake, the classic snake looks kind of like that. It starts out increasing at a decreasing, and then changes at that moment to increasing at an increase. But that's not the only one that does that. X to the third does it, but what else does it? To the 7th, yes, you skipped over one there. X to the 5th, yeah, the 5th, the 7th. Okay, any odd number would look like that. I want you to prove that to yourself. Why don't you type in y equals x to the 5th, and just kind of take a look at what the graph for that looks like. I bet you'll see it looks a lot like x to the 3rd. All right, now we need to know a few more parent functions. Do you remember this one, y equals 1 over x? Graph it. That was the old parent function that you're expected to know. And it looks kind of like that. Right? Remember how it had asymptotes in it? It was the first major graph that you had that had asymptotes, especially asymptotes in both directions. Asymptotes there and there. And do you remember then if I wanted to move it to the right, I could go like -2 down by the x there. Keep it down in the denominator. That would move it 2 to the right. And then how about if I want to move it up 7? Plus 7, like that. Remember those? Okay. Now, we got a new parent function. There's a new sheriff in town. Now, it's very similar, but would you please graph 1 over x where the x is squared? So now you have a new parent function. So who's your daddy now? That one is. Did it look like that? Okay. Let's talk about why. Why would it look like that? Well, before I had things down here where x was negative, and then now it's being squared. So can you have things that'll still be negative then? No, they're going to get positivized, so to speak. Okay. So now, if I took that and I wanted to move it like this, what's that going to do to it? I'll move it down 3. The whole thing will move down 3. Okay. Is there an asymptote involved here? Oh yeah, there's 2 asymptotes. There's an asymptote running this way, and there's an asymptote running that way. If I subtract 3, do you get that that's going to move the whole thing down 3, and therefore the asymptote will move down 3? So this asymptote that was going across is now going to be going across down here, 3 spots lower. Right? All right, so let's talk about this in terms of asymptotes then. Do you get that the asymptotes for this, there's either vertical or horizontal? And the vertical are x equals things, and the horizontal are y equals things. Remember that? All right, now I got to change what I told you before and tell you more. All the problems in the past that we did would never have a little number off to the side like this. When we asked you like bigger on bottom, bigger on top, same on both, we never messed with that number over there. There wasn't a number over there. If we had a problem, it was just like this, 1 over x plus 5 or minus 5 or whatever. And then we'd say if it's bigger on bottom or bigger on top or same on both, you use these different rules. Remember the bigger on the bottom rule was that y was equal to 0? And it is, unless you move the graph up 5 places, for instance, like that. Then it won't be at y equals 0 anymore. What will it be at? 5. So instead of saying Bob is a 0, the better thing to say is that if there's nothing over here, then it's like adding 0. Bob, bigger on the bottom one, is always going to be y equals whatever's on the outside. You know what I'm saying? Bob is an outsider. No, Bob's not a 0. Bob's an outsider. So go back to this. Do you see that this is a Bob? It's a bigger on the bottom because there's a squared in the degree here. Bigger on the bottom means y equals not 0 anymore. Y equals whatever's on the outside. That happens to be a 0 on the outside because there is no number here, then fine, it's 0. But if there's a number, it's that number. So horizontal is now y equals -3. And look at it. See, remember, we moved this whole thing down 3. It makes sense that the new asymptote should be that black line there. Okay? So when you're asked to find the verticals, that's the x things. That's just whatever makes the bottom 0. Do you get that if I put a 0 there, there'd be a problem? The 0 squared would give me a 0 on the bottom, and that's not good. That's why there's an asymptote at x equals 0. All right, so let me give you another one. Let's say I had a much more complicated one. 5 over 7x squared plus 15. What are the vertical and horizontal asymptotes? The verticals, you ask Bob about those. These are almost all going to be Bob's today. Figure on the bottom. And what's the new rule for Bob's? He's not just a 0, he's a outsider. So if there's something on the outside, my verticals would be x. Wait a minute, that's not a vertical, that's a horizontals. Sorry. I was talking about horizontals the whole time, but I put a vertical on the board. The horizontals are the Bob things. The Bob things are y equals things, and this is going to be an outsider, 15. The verticals, on the other hand, are the things that makes the bottom 0. Is there anything that would make the bottom 0? 0. So the x equals 0 would be my asymptote vertically. Okay, remember that? Verticals are the stuff on the bottom here. The horizontals are the ones Bob will tell you about. Bob is no longer a 0. Bob's an outsider. All right, so now if I actually graph this thing, do you get that this y equals 15 spot's kind of important? Y equals 15 would be like here. The whole thing's been moved up 15. All right, and it's still got an asymptote at x equals 0. And do you remember that generally these things are this shape? And then what is this 5 going to do? I'll give you a hint. Just like it was in front. See, if I move it here, it would be in front, and it would still be the same value. It's like I could times it by 5, or I could have the 5 here, either way. So if having it in front like that might be kind of a hint that the whole thing is stretched up 5 times as tall. But do you get this is still heading towards that asymptote, so it really doesn't matter that much if I stretch it 5 times as tall. And this 7 here means the thing theoretically is supposed to be not 7 times wider, 7 times narrower. So again, it's just going to be a little squished in a little bit more, but it's still heading towards the same asymptotes. What moves the asymptotes is things like this on the outside. Or how could I have the whole graph move to the left or to the right? If I put something in here like -5 or... Now that would make the whole graph move to the right or the left. That would change my asymptote right or left. So let's look at one of those. Let's say I had 1 over 5. Let's make it x plus 5 squared plus 15. Okay, is it bigger on the bottom, bigger on top, same on both? Bigger on the bottom. And what's the rule for Bob? Outsider. What's y equal to that? 15. How about the x one? What makes the bottom 0? Do you see how that automatically changed my asymptote on my x is not a 0 anymore? Because -5 is the thing that would make my bottom part be 0. Okay? So if you just follow the rules we've had before, your horizontal and vertical asymptotes are all the same. Now you can sketch the thing and say, okay, I know there's a line going across here at 15. I know there's a line that's going across at -5. And I know generally what these things where it's 1 over x squared look like. They look like that. And so now I got my graph. The last part is they're going to ask you for the asymptotes then. Sorry, we just did that. The limits then for this graph. All right, so let's get a nice graph so I can focus on that and say, all right, let's say we had one that was shifted up and then over, and then my asymptotes look kind of like that, and then here's my graph. It's kind of like that. And let's say that this is at 3 right there, and then this is at 4 down here. And so, tell me, the end limits. Give it a shot yourself. Limit of the function as x approaches whatever. Give me the end limits. You already know how to do that. You really only have to add one thing to it. So there's a left end would be limit as x approaches, well, where's the left end? It's way over there. So x approaches negative infinity. And if I go way, way, way over here, my graph will get closer and closer to what? 3. And then the right end, I'll do that in green, limit of the function as x approaches, if I'm going to the right, I'm way, way, way over there, and so it's approaching infinity. And that would be, when I get way, way, way over there, my graph gets closer and closer to left end, right end. Do you get those? Raise your hand if you feel like you get those. Okay. Some of you may still need to work on that. I'll help you one-on-one for that, since almost everybody knew it. Okay. The next part is, the limits way out on the ends are one thing, but what about the limit as I get closer and closer to this one? Instead of talking about where I get closer and closer to infinity, I want to get closer and closer to the other asymptote that's going up and down, that's also known as a vertical asymptote, at 4. All right, so how can I do that kind of limit? I'm going to erase these just to have more room to write stuff. They still look like the same exact thing. Remember how I said all limits are going to start with this lim of the function as x approaches something, and then it always equals something. And I just need something here and something here. Who knows one of those two things? If I'm going to go towards the middle, what do you think I'm going towards? So as x approaches 4, very good. Do you get that it kind of depends on which side you come from as you're going towards the middle? In this case, the answer is going to be the same. If I come from way over here and I ride in on this line, it's going to force me up to positive infinity. Or if I come from this side over here and I ride in on this line, getting closer and closer to 4, it's going to force me up to infinity. So the answer is infinity either way. Okay, so let's just talk about why do I have to do it twice then? Because some of the graphs are going to be different. Let me finish this one. I would say as x approaches 4, from the left, which would be where the negative numbers are, that'd be way over here. I'm over here and I'm approaching, I'm getting closer and closer to 4, it forces me to infinity. There's my answer. Or I could have the other one, limit of the function as x approaches 4 from the other side, which is from where the positives are, that would also be infinity. Because I start over here where the positives are, and I get closer and closer to 4, and it forces me up to infinity. This will make more sense when you see a graph like this. Let me do it all one color, I guess, and I'll do the asymptotes in a different color. Asymptotes like this, and this. Okay. The limit on the left end and the right end is going to be whatever that green line is at. Let's say that it's at 5 right there. If that's at 5, this black line might be at 6. Okay? So tell me, what are the two limits that come towards the middle? Give it your best shot. See if you can do it. It always starts with lim. F of x. It always has an x and an arrow. X approaching. Tell me the limits that are heading towards the middle. And the middle are always the ones that go up and down. They're the vertical asymptotes. Lim of the function as x approaches. That's how you always start. Now, what am I approaching? If I'm getting towards the middle number is 6. Good. X approaches 6, but I can come from either direction. We can start from the positives. That'd be like way over here. Yep. So then that's from the positives. Just put a little plus. And then I'm going to write in, and I jump onto this line, and it would take me up to positive infinity. Raise your hand if you had that one right. Good. And the other one is the same thing, except it's coming from the left, so I say it's coming from the negative x's, which are over here, and it rides in and jumps on this track and is forced to go down to negative infinity. Do you get that? So it's basically just kind of limits that instead of going way out to the ends, they're limits that are coming towards the middle. All right. So let's do some of the problems off your homework. Here is your new homework. All right, number one. It seems simple because it just has a nice little function there, 1 over x minus 3. But it has like 8 parts. First part, describe how the graph of the given function can be obtained by transforming the graph of the parent. In other words, what changed from the parent? Not 1, right? 3. There you go. So number 1, the first thing you'd answer is right 3. That's all you have to do is take the parent and move to the right 3. Okay, and what's the rest of the question? Identify the horizontal and vertical asymptotes. What I'd like you to do is put h with a colon. That'll imply that's your horizontal asymptote. And the horizontals are the y equals things. Notice the h and the y are like flipped upside down from each other. Don't forget which ones are which. And the verticals, colon, are the x's. Who do we ask about the y equals thing? Bob. And remember, Bob's not just a 0 anymore. He's, what, an outsider. Is there anything outside here? So it's sort of like there's a plus 0 outside, right? So what is it? Y equals 0. And the x part of it is what would make my function crash? 3. So x equals 3. Those are my two asymptotes. Now, it's eventually going to get around to asking you to sketch it, so I'd like to sketch it now. It says sketch the graph. So I'd like to sketch it. So make a quick sketch. And we know what the parent looks like, right? Except we got to move to the right 3. Here's the 2 parent points. Just grab those, because they would like go like this normally. Grab those and move them over 3. So they'll be like that. And now the asymptote, notice one of them's changed, one of them's the same. My graph kind of looks like that. This is a sketch here. It's not a actually graphing test where you'd actually have to make it all perfect. That's good enough. So now, what's the last part? Use limits to describe the behavior around the vertical asymptotes. And then use limits to describe the end behavior. So there's 2 limits for each kind. 2 limits as you get towards the middle, those are the vertical asymptote ones, and 2 limits to do the right end and the left end. So there's really 4 limits you got to write. Lim of the function. As x approaches, and then I say equals, that's the framework for all 4 limits, and I'm just going to use the wonders of technology here to clone this. Infinite cloner. There, there, and there. There's my 4 limit things. They're all start the exact same way. Now one of my limits goes to negative infinity. That one is my way left end limit. If way on the left, what would this thing be? Nope. Way to the left is like this. What would the y be? Nope, not 3. As it gets way over this way, it's going to get closer and closer to what? 0. It's getting closer and closer to 0. Okay, next I'm going to go to the right side at positive infinity. That means I'm heading way this way. I go way that way. Where does my graph get closer and closer to? It's closer and closer to 0. Okay. Now I got to go towards the middle, or the vertical asymptote. Vertical asymptote here is at 3, so I'm getting closer and closer to 3. But I got to come from 2 different ways. I got to do 3 from the positives, and then I do 3 from the negatives. All right, so if I'm doing to come closer and closer to 3 from the positive side, that means I'm over here. That's where the positive x's are. We're talking about x here, right? See? And so I'm starting way over here, and I get going this way, and I'm going to jump on this track right here, and it's going to force me up. Just positive infinity. If I'm going to get closer and closer to 3 from the negative, starting at where x is negative is like way over here. And if I'm going to come in, I'm going to come in on this track here, and it's going to force me down to negative infinity. There we go. Those are the 4 different kinds of limits. Outside, the end limits, and then the inside limits, which gets closer and closer to that vertical asymptote. All right. Let's skip down and do problem 1 in the next section. Mrs. H, would you read me number 1 in the next section? Ms. H, I should say. 1 over what? And is it plus 4 with the x, or is it on the outside? Like that? Okay. Do you remember what the parent one looks like on this? I do. Looks like that. Remember that? Okay. And then this guy is going to get moved where? Up 4. Okay. So I'm going to unsketch it and draw it again. Moving it up 4. Like that. That dotted line is supposed to be at 4. The one that's the horizontal one. Okay. They want to know a lot of things. They want to know how can you graph the one from transforming the other. Well, this one's just been moved up 4, so I write up 4. So first part of the answer is up 4. Next thing they wanted to know was identify the horizontal and verticals. Horizontal are y equals. Verticals are x equals. You got to keep those straight. And then which one are they? Well, y equals, that's a Bob thing, and this is bigger on bottom. Yes, it is. And so what's Bob? He's the 4. He's an outsider. So it's that number. If there is no number out there, then it's 0. The verticals are the things that crash it. What would crash it? What would crash this function? 0. Okay. And now, use limits to describe the end behavior. I got my sketch on my graph already, so I'm good on that. I like to sketch the graph before I do my limits. It's way easier for me anyway. Once I got the picture, then I can look at the picture and figure out what the limits are. So now I got to do my 4 limits. Lim of the function as x approaches, and then this is going to be equal to, and I'm going to make this an infinite cloner. I know you can't do that, but I can, so I'm going to. Here's my 4 limit statements. One for the left end, one for the right end, and I'm just going to put in those parts. Negative infinity, that's where x is negative infinity, it's way to the left. That's the left end. That's the right end. Now as x approaches 0 from the negatives would be the left side, and 0 from the positives would be from the right side. And then you can answer those 4 limits. Okay. If you look on the back side, I think you'll find that those are pretty easy. All right. That's all I got for you. You got a bunch of time to work.